All right. I'm going to record this with something a little bit different here. So we'll see how this works. We're going to look at lesson 4.3, which will include the first derivative test for local extrema. We'll talk about what is meant by concavity and points of inflection. We've got the first derivative test here. We will talk about what the second derivative test is and when we should use one, when we should use the other one. And then we will talk about, maybe get to learning about functions from their derivatives. Okay. Because differential calculus is a powerful problem-solving tool precisely because it is useful for analyzing functions. All right, so first derivatives and local extrema. So we've seen a picture kind of like this before. We're going to kind of highlight what is going on here in particular. Okay, I think I've got some extra things in there that don't necessarily need to be there, so we'll get rid of those. All right, so this shows an example of, over on this end, we have an absolute minimum that happens to occur at an endpoint. So we know that endpoints are a place that we need to look at. This is just a local minimum because this other minimum on the other side is lower, smaller. Okay. And then we've got, along the way here, are other things that are going on. We have a local maximum here, because we had a peak in the graph, local minimum where there was a valley. We've got a local maximum here that's happening in an unusual way there. Okay. And these in here, as it indicates, the derivative is 0 at that point. So it told us there was a horizontal tangent here. And so places where there are horizontal tangents, those horizontal tangents tend often to sit either on top or on top of a mountain or at the bottom of a valley. Okay, this one is a max up here, but there is no horizontal tangent on this one. The function, the derivative, is undefined at this point. That's what made that a critical point. So remember, we said our critical points are any place that the derivative is either 0 or undefined. Derivative is undefined there because that is a corner point. We have these other places, though, where the derivative is also 0. Okay, here's a place where the derivative is 0. The slope of the tangent line is 0. It's a horizontal tangent at that point. And that is not a maximum and it's not a minimum. Okay, so we have to understand that our critical points don't tell us that every place the derivative is 0 or undefined, that there will be a maximum or there will be a minimum. It just says these are the places that you need to look for them. Okay. So what would be of value to us is if we have the list of places to look, our endpoints and our critical points, the places where the derivative is either 0 or undefined, okay, is how can we tell what's actually going on there? How can we tell if it is a maximum or a minimum, or if it's one of these other weird things that's going on there? Okay. And what we get is that the other information about the first derivative reveals what is going on. So these other things that are going on here, okay, endpoints, the derivatives don't tell us really anything about endpoints. Okay? But this one right here tells us that between A and C1, and C1 is definitely a critical point. Okay, it's a place where the derivative came out to be 0. To the left of C1, the derivative was positive, which is an indicator that the function was increasing at that point. To the right of C1, is just as to the right, and before we get to our next critical point, the derivative is still positive, which tells us that it increased and flattened out and then continued to increase, which is not a pattern that leads to an extreme value. Okay? You can imagine those years before they had all the graphing technology where they had to reason out what these things meant without really having a picture in their head of them. Okay, so let's move to our next one.